Hello everyone. In this session, we will model and design a steel composite bridge. We will model it as a grillage model, three-dimensional. So to start the project, we will go to project configuration. You can enter the name or number of the project here. For the analysis, I will define nonlinear analysis. And because the project is a composite beam, so I will define construction stages here. In this project, I will use stage 1, 2, 6, and 7. The long-term effect will be 3 as n, and the short-term n will be 1. So I'm leaving this here as default. And we are going to use the stats in negative bending zone. So click OK. In the next part, I'm going to define a new concrete material for this project. So you can always choose one of these already defined materials and modify them. It's much easier. So let's say Control C, Control V, and I'm going to change the name to composite concrete 0 through T. So here you can enter the modulus of Young or modulus of elasticity, as you see here. So all of the numbers here, they're fine. So I'm going to leave them as you see here. We have the F prime C as 30 megapascals, and the density is 23, and it is a public distribution, so I can use this kind of material in other projects. So click OK. Also, I'm going to use two kinds of custom sections in this project. So my steel beams will be I sections. I select them here. So as you see, there are so many already defined sections here. So you can always add a section. Also, you can add your member here. As WRF shape. So if it is a plate girder, you can use this type of section. So here in this project, let's go with a steel plate girder. I'm going to use this section, copy it, and paste it here. And I'm going to change the name to, let's say, MTO Composite 1 to 8. In this project, we will have portions of beam each portion will be 8 meters. And for the middle part of the bridge, I will use other kind of plate girder other than the sides. So you will see that. And here I'm going to define the less stronger section here. So it will be composite 1 through 8. And also I'm going to copy and paste same name here. Okay, the material will be steel. It's a steel plate girder. So, and here are the properties of my I section. As you see here, I have entered. So D is 1820, B1 is 400 millimeters, T1 is 330, and B2 is 500. T2 is 40, W is 14, and others are automatically calculated by ADA. And if you want to check the section visually, you can always right click detail, and this is the properties of the section. Okay, and I will define another section for middle portion of my bridge. So again, I'm going to copy and paste a section from the library here. So here, Control C, and Control V. You can change the name. Same name for the second column. And you can insert the properties for the second section here. As you see, we have much higher height here. And also the width of the flange is different. So the second section is stronger than the first one. And I'm going to use the second one as portions 8 to 11. The first one will be portions 1 to 8. You will see those right away. So, and to check the details of this section also, I can check it here. And as you see, I have my B1 570 millimeters, and T1 in this case is 51, B2 is 600, and T2 is 60 millimeters. The thickness of web will be 14 millimeters. Okay, so I have defined my steel sections here. Click OK. The next part is to define the slab for this project. So we go to Structure, Slabs here, and we need to define a new slab here. So I'm gonna name it as slab composite. Okay. For concrete material, we will use the same material that we have already defined. So it was composite concrete 030. Okay, so we don't have any steel deck. The concrete thickness in this case is concrete thickness is 225. No hunches. And for this one, which is the side portions of my bridge for the less strong member or less strong eye girder, Actually, I can change name here to make things more clear. So I'm going to name it as 1 to 8. So we can easily select this as a slab for our weak beams. So this will be the same thickness, but the reinforcement will be different. So here, the top reinforcement, I'm going to define it as 15 m's. And bar spacing at top will be 300. Distance D, I'm going to put it as 155 millimeters. For the bottom, again, it's 15 m's. 300. This one 185 for the cover. And the grade, I'm going to define it as grade 40. Or 400. And I'm going to define the other slab for the middle portion of the bridge. So this one will be named as portions 8 to 14. Same material for concrete. Same thickness. But here we will strengthen the slab because it's the middle portion. So for this, I will use 25 m's. Bar spacing is less, 150. This is for top reinforcement. The cover 155. And for the bottom, it will be again 50 m's, 15 m's, in 300, 185, and 400 W material. So here I've defined the slabs. Click OK. In the next step, I will define the geometry. So we can always go to the node activation, Control H, add node. So the first node will be node number 1, starting from 0 coordinates, and it will be a support. The next one will be also a support, node 2. And I'm going to define this as 48 meters because the bridge has 2 spans of each 48 meters. And node 3, support, another 48 meters, which will be 96. Okay, so as you see here, I have my supports. So I will release some of the constraints on these 2 sides of the bridge. So click Control H. You need to be in support activation mode first. Select the supports and Control H. So here, as you see, for the X direction, I will leave them as they are, so they will be closed along X coordinates. For RY as well. For RZ, I will release them. Also, I will release them for all of the moments, so they will be simply supported. Okay, so as you see, for the middle one as well, Control H to bring up the spreadsheet. So for the middle one, our X will be closed, our Y will be closed. And also for this one, I will close the RZ. So we will have a restraint along the Z axis, and the other ones will be free. So we are not going to have any instabilities in this direction. And the spans will be free to expand. Okay. The next part is to add the members. So I add the first span here. Everything is okay here. For the properties, for now, I will define my WRF, which is already defined as custom sections. So it's here into composite. And right now for the first portions, I will define the first section here, 1.8, okay. For the material, I will use steel G40. $350 For the dead load, I will add a new one here as steel. So the type will be a dead load or prefab component. And I want it to be automatically calculated. And we will leave the dead load here as is. Click OK. So here I'm going to assign the steel load case to this member. I will activate the design because I want it to be designed. And it is a composite beam. Okay. It will be activated from stage 1. So, and also I want them to be aligned top. And here I'm going to define the slab. So it will be the first portions, 1.8. Stud 22 millimeters. Effective with 3000 millimeters or 3 meters. Number of studs, I'm going to leave it as 2. We will remove this check mark because it's an stage construction, and add these 3 to have the composite effects. Okay, so if I go to 3D view, I have the beam here, and here I'm going to add the other span from this node support to the other support. So as you see, everything is defined here. Okay. We need to also activate them activate the composite behavior from stage 6. So composite beam, and we change it to stage 6. Okay, and also for the other one, composite stage 6. So the composite section will be activated from stage 6, which the slab is hardened. Okay, so to define the other portions of this bridge here that I've already mentioned to you, these parts closer to the middle support, we will use a stronger section. So I'm going to divide each of these long members to 6 portions. So here we have the tool, multiple split, and each one will be divided by 6. Save the project as composite. Okay, as you see here, ADA has divided these beams to each one for 6 portions, and each portion should be 8 meters, as you see here. Okay, and now we will change the section and the slab for these 4 portions here to have much stronger section. So I click these 4 portions, Control H, so here you have all of the properties. I'm going to change the shape to 811, the already defined custom shape. Material is same, dead load is same, and also we need to change the slab. So here, as you see, the slab is 1.8 for these, so I will change them to 8.11, the more stronger one. Okay. So if we check them out from the side view, we will see that it's already changed. In the next step, we will define the design specifications. So structure menu, specifications, steel. I will add one here as a 6 verification. So the standard or code, it will be for this project I'm using S606. Type of analysis is verification, so ADA will not design or change the sections, it will just verify my already defined sections. And other default values are okay, so click OK. And now we need to assign this design specification to our members. So we will go to member activation, select all of the members, Control H to bring up the spreadsheet, and here in Steel Design tab, we will assign a specification to all of the members. So replace to S6 verification. Okay. And also we will activate the lateral support for these members at both ends. So we will have we will define lateral supports at each 8 meters that we have already intermediate diaphragms. So also for node J, I assign lateral support for the top, yes, and also for the bottom. Pardon me, for the top at node J. Okay. We don't have any longitudinal stiffeners. And here, but we can define some transverse one because we have diaphragms there, members from diaphragm. So I define them as 8,000 meters, 8,000 millimeters or 8 meters. So click OK, and right now if you check one of the members in Steel Design, as you see, specifications is defined. Here I have the lateral supports, and here I have a spacing for stiffeners for my bridge. Okay, but we need to change this number of the stiffeners here. I'm going to put much smaller distance for the stiffeners for this portion of my bridge. So here, and we go to Steel tab, and instead of 8,000, I will define them as 2,600 millimeters, or 2.6. Okay. So double click, and as you see here, I have 2,600 millimeters. Click OK. Now that we have defined one of the beams here, we can start to make the 3D model. The easiest way is to just copy and paste it. I will have 4 beams. So I select the members, also the supports, Control C, and I will copy them along the X coordinates as 3 meters. Now we can push Control V to paste, And if you continue to just pushing Control V again, you will have the third and fourth one. So as you see here, ADA has copied this first beam, and now I have all of my 4 beams here. The next step is to dividing these members to even smaller members to have more refined model. And because we are going to define some slab members between all of these beams, so it's better to have some nodes here along these main beams. So before doing that, I will select all of the beam members and define a selection for them that afterwards it will be very useful for us, these selections. So to define a selection, as I have already explained, we select all of the members and hit Control L and just name them. For example, I name them as beams. Okay, so from here on, if you want to select all of the beams from the model, we can just go to selection mode and click here beams. Okay, and beams will be selected. So right now I'm going to define each of these portions, which each of them is 8 meters. I'm going to define them for 4, so I will have each portion as 2 meters. So use the split tool here. 4. Yes. Okay. So here, as you see, all of the members are divided for small 2-meter beams, and all of the characteristics will remain. Click OK. The next step is to, because we are going to define slabs on the edge of the bridge, we need to define some members first, and afterwards we will define the floor elements to cover those members. So here I already have my beams, but in the outer edges of bridge I don't have any members, so I'm going to define some small members there that they are not so effective for the stiffness of bridge. They're just their purpose is to just helping us to add the floor members later on. So to add those nodes, I will use the copy paste again. So you can just select these nodes here and this one here with holding Control and Control C. I'm going to copy them in -x as 1.5 meters because I want to have the edge of the bridge the width will be 1.5 meters for this bridge. Okay, Control V. Now if you make some mistakes like this, so you can just hit Control Z to undo it, select the nodes again, Control C, and -5, -1.5. Okay, Control V. So right now I have the edge nodes here. So we need to change them as simple nodes. They are not supports. So Control H, select them, Control H. Replace them with normal. Again, I'm going to copy these two nodes to this side of bridge, because in this side also we will define overhang. So select two nodes. As you see here, I have two nodes selected. Control C, X direction, and here will be width of the bridge, which is 12 meters. Control V. So I have the new nodes here. And right now we can add those members. So add member from this node to here. So these members, we will not design them, and we will not define any dead load for them. So the section that I'm going to use here, we have some special sections here as trans G, that they are simple linear sections. They don't have much of a stiffness for bending or shear. You can define another kind of members here to cover that area. In this model, I'm going to use this member, okay. And they don't have any dead load. They will not be for design. They are standard. Okay. The stage is not applicable even for them. And here you can put them as aligned as center. Standard. Okay. So I have that member here, as you see. And to align them with the other nodes here to add the floors later on, so we can divide this member to 48 portions, that each portion will be 2 meters and my nodes will be aligned. So multiple split, 48 portions, subdivisions. Okay, and as you see here, I have new nodes generated here, and it will be possible for us to define our floor elements between these 4 corner nodes to define the overhang of bridge. So we can do the same procedure here. So again, I'm going to add a member for the other side of bridge, starting from this node to this node. So same section, no dead load, no design, okay. Select it and split it for 40. Okay, so I have my notes here. To make the modeling easier for us for the later modeling elements, here I'm gonna define a selection for these edge members also. So if we go to top view, restricted window, select those. No, write this. Okay. Also this side, holding control, mask them. So here you see the edge members, and we will define a selection for them. So Control L, and I name the selection as edge members. Okay. So right now, when we have the full model, whenever we want to select these edge members or beams, I have the selection to select those much more faster. Next stage is to define the floors, and the floor elements in ADA will help us to distribute the forces between the beams. And the floor elements in ADA, they don't have any lateral stiffness, so we will also define some members to account for that lateral stiffness of a slab. But here the floors will help us only to add the forces, gravity forces or other loads to the bridge. So to add these floors, I'm going to deactivate the 3D display. It will be much easier for us, and we will add these floors here between the beams or members. So we go to the add mode, and here are the floors activated, and we can draw them by just clicking on the 4 corner nodes. Okay, as you see, the floor is there, and this is the floor characteristics. So they will be one way, and no self-weight yet, because we will define the self-weight of the slab concrete manually. And the bearing direction, it will be J, K, and Li. The behavior, we don't have any stiffness. Okay. So as you see, the slab is defined here. You have the geometry, and to see these, the load bearing sign, you can always come to here, view options, attributes. In the floors, you have the one-way symbol here. So as you see, the load will go to my main beam here, and also this member, that because it's a weak one, so most of the load will be transferred to the main girder. I'm going to add another floor element between these other members or girders, so same procedure. And same properties. Okay. Okay. And for the final one, okay. So here are the floors for this bridge. And because I've defined equal distances between my nodes, so it will be easy to just copy and paste these floors along my bridge. So select the floors, Control C, and I want to copy them along Z, and each distance is 2 meters, so minus 2 meters. Okay, Control V, and as you see, they are copying like this. And if you keep on hitting Control V, you see the members are continually pasting, and they're covering the bridge. Okay, so as you see, the floors are defined for the bridge. I'm going to define a selection for floors as well. So select the floors, Control L, and I'm gonna name it as floors. Okay. Next, as I already explained, because these floors cannot transfer any force laterally, so we will use some members to connect the main girders transversely. So to define those members, they will be custom. So we can go to common shapes. So there will be new rectangular shapes. And I'm going to define them as transverse beam. Same name here. The material will be concrete. The height will be 225, same as our slab. And the width will be 4,000 millimeters, which covers 2 floors here, like this. So each floor's width is 2 meters. So I'm going to define my member just here, and it will cover 2 floors. So 2 floors will be 4 meters or 4,000. You can check the details always here. 225, 4,000. Okay. Click OK. So now we will add the members. I start from here. So add, activate the member. So a member here. Their section will be concrete, rectangular, and here, as you see, we have the trans beam. Okay. There will be no dead load for those because they are we are defining their because of their stiffness, and the dead load from slab will be applied manually to the floors. We don't need to design them also. And they will be activated from stage 6, which the slab is hardened. and their connection is okay. So the member is added here, and also I'm going to add the others for this span. Okay, next one. And the final. Okay, if I activate the 3D display, you will see that these members already placed there. This one you see here, and also I have another one here, and this. So these are the members that will act as to transfer the lateral forces between girders. So the next thing is to copy them. From each 4 meters. So Control C. It will be Z direction -4 meters. Okay, and Control V. So as you see, they're copying here. And the final ones are here. We need to define a selection for these members also. So I'm going to select them. Select all the members. Okay. So here I have just the linear members. We go to selection mode, select beams, edge members, and floors. Okay. Invert the selection, Control I. So right now, just the members, the stiffener members are selected. I mask them here. And as you see, we have just these members. So if you select the linear again, mask, okay. Right now, what you see is just our transverse stiffener members. So select them, Control L, and define them as trans stiffener slat. Okay. Save the project. So in the next step, we need to connect this member to the supports or the beam. A tool that we use in ADA to connect or have rigid connection between two nodes is using a rigid link. So I'm going to use rigid link here, addition. It's a kind of a linear member. So we have added here between this node from the beam to this member. And here we have behavior rigid. So if you select this, I have the rigid member defined there, and I will release one side for torsion. I don't want the torsion to be transferred, so okay. As you see, the member is here. I'm going to perform same procedure here. Okay, and the other corner bridge. Okay, and the final one. Okay. So this one will connect these edge members to my beams. This concludes our modeling today. So please just make sure to save your model, because we are going to use this model to continue our next session on bridge grillage modeling. Thank you very much, and I hope you enjoyed this session.